So we're going to talk about identifying algebra tiles. So I'm going to show you some of the basic algebra tiles that you're going to be using when you're using them online. So you have x squared, which you can see is in the shape of a square. Then you have x, which is similar but not quite the same size. Then you have y squared and y. Then you have xy and then 1. Now, one thing I want you to notice when working with algebra tiles online is that if you click on them, notice they turn red. And when they turn red, that just means they become, as you can see, negative. So if I click on these, they all turn red. So all the tiles will do the same if you click on them. The other thing is with the tiles that don't have the same length sides on all sides, if you double click them, they flip or turn. Now if I grab another x from over here and I flip this, I want you to notice how this square is x wide, but also x tall. So x times x gives us x squared. Hence why it's x squared, because it's the length of x on both sides. Same thing is true for y. I flip this around. The y squared is both y wide, but also y tall. Hence y times y is y squared. Now with the xy, you'll notice that it's x tall, but then x wide. So x times y is xy, of course. So if we're to go over here and take a look at these tiles that were put together, we have to come up with an expression for that. So notice here we've got x squared. So that's basically 1x squared. And then we have 3 x's. So the way I'd write that is 1x squared for that tile there, and then 3x for those 3x tiles there. And then as we know, for the 1, we can always take that away, and now that just becomes x squared. And now your final expression is x squared plus 3x. Another example, notice how the tiles will sometimes be different colors depending on what program we're going to be using, but it's still the same idea. We have y squared and x squared. There's no other tiles, and these aren't the same. So I can't just add the tiles that are different. So I'm going to write that as x squared plus y squared separately. Okay, now sometimes they're not going to be in color, and they're going to be in it'll be in white and some kind of gray color. In that case, now your white tiles are negative, as you can see here, and the grayed out tiles are your positive ones. So here, for example, the expression is going to be negative 2y plus 3x minus 3. And I'll show you why. So first of all, you have these two negative y's, because remember they're white, so that makes them negative, and there's 2 of them. So if there's 2 of them, then I write negative 2y. Then I've got 3 of these x's here. They're all positive, so hence 3 positive 3x or plus 3x. And then lastly, the 1's here, they're all negative because they're white, and so we put minus 3 at the end. And then you end up with this final expression. Okay, here another example. Again, the answer is 3xy minus 2x minus 2, because here I have 3 xy's. And notice that I'm only putting the ones that are the same together. And so I write 3xy. And then the next terms would be these 2 x's here, but notice how they're both white, so that makes them negative, so negative 2x. And then the last one, I've got these 2 white colored tiles or white colored ones, so then I have minus 2. So now let's say that I've got $4, but I owe my friend $3, hence the 3 negative ones. So if I owe my friend $3 and I have 4, that means that for every dollar that I owe him, I'm going to have to take one of those away. So these $3 that I have here, I have to take away because I owe him that. So if you notice, what I can actually do is click and drag, and it highlights those, and I can pull those away. And I can actually pull those off the screen, and now they disappear. And so hence, how much money do I have left? $1. So this new expression, again, kind of the same idea. For every positive and negative I have, I can take one away. So here, these are called zero pairs. So if I take a positive x squared and a negative x squared, that goes away. Here's another one. Every positive and negative, I can take one away. For every positive and negative, I take one away. And then there's my final expression, which is just negative x squared. Okay, so now in this one, kind of the same idea, you want to look for those zero pairs. Now here you have y squared and y, and some of you might think, oh, what if I just take these y's and make a zero pair with this y squared? Well, if you notice, if I try to actually lay these on top of this square, they don't lay perfectly. Notice how there's this little wedge left. So it's not quite a perfect fit. So that's not going to work. Those aren't zero pairs. Now, here for xy, notice how if I take that xy, it lays right over the top. So those can be taken away as a zero pair. So now what I'm left with is y squared minus 4y's plus 2xy's. Okay, so the last example I want to show you guys is now let's use that idea of zero pairs in an expression like this. So notice here that we've got some negatives here in the white, and the positives are the grayed out ones. Well, that first pair of y's there, that's a zero pair. There's another zero pair. So I can pretty much just cancel those out. Okay, so now all I have left are these two negative y's, so my answer is negative 2y. Okay, that's it.